I'm Mark Kavanaugh for Cavi Coaches, and today I'm going to coach you up on calculating an experimental value for the density of water. Alright, so the lab setup we have today is I've got a graduated cylinder that has water to about 300 milliliters, and I've got some hanging weights. And I also have a Pasco force sensor that I'm going to use to measure the force when the mass is completely submerged in the water. So what we're going to do is we're going to collect some data. I'm going to tell you what the masses are. I will show you a video of the volume and how it changes, and we will also record the force that is being read by the force sensor once the masses are completely submerged in water. Alright, so we're going to draw our free body diagram for the hanging mass in the water. So you can see our system schema here. We've got the tension force of the force sensor, we've got the gravitational force of the earth, and the buoyancy force of the water. So we'll go ahead and draw the gravitational force. So that takes care of the gravitational force. Now we're going to draw the buoyancy force. And lastly, we're going to draw the tension force from the force sensor. This is our free body diagram. Next, we're going to add our second law equation. So let's write out Newton's second law. From that, we'll apply to this situation. So we've got the upward force of the buoyancy force, tension force, and then the downward force of gravity. And in this situation, since acceleration equals 0, we're going to go ahead and set these equal to 0. We want to rearrange this equation because what we're trying to ultimately find is the density of water. We know the tension force from the measurements we took in our lab experiment, and we know the masses, so we can easily find the gravitational force. So we're going to substitute the equations in for each of the forces that we need to calculate. So rho Vg for the buoyancy force, the tension force we know, and we can have mg for our gravitational force. Now we're going to solve for the buoyancy force. So we're going to go ahead and we're going to add mg to both sides, and we're going to subtract ft from both sides. That'll leave us with mg minus ft is equal to rho Vg. Now from this, you need to figure out the experimental value of the density of water using the values that we had. So you're going to create a straight line graph in which the slope will help us either find the density or will be the density of water. For submitting solutions, you can go ahead and submit a solution to my Google Classroom page is linked using this code right here. Have a great day and an even better tomorrow.
If you found this video helpful, don't forget to subscribe to my channel, Cavi Coaches, and follow me on Instagram and Twitter @CaviCoaches.